All right, so since we've talked about common logs and natural logs, again, common base 10 and natural base E, we're now going to talk about the change of base formula. Now, this is a very simple but a very powerful formula. It's most likely going to be the most applicable concept in dealing with logarithms. Remember when I asked you how to solve an exponential equation like 3 to the x is equal to 50? There was discussion on what should we do to both sides to do this. Could we divide by 3? Could we take the xth root? None of that really made sense. Okay, but now, of all the types of formulas that we've used, we can, just like any other thing, we can take the log of both sides. And if I do that, by log property, that power can be moved in front. And now x times a log of 3 would equal the log of 50. Solving for x, then I would divide by log of 3. And these cancel. So to solve the equation 3 to the x is equal to 50, I can just do log of 50 divided by log of 3. As you can see, there's no bases visible, so that's assumed to be base 10, and that can easily be done on your calculator. Now, you should see that if power of 3 that gives you 50 should be something between 3 and 4, because 3 to the third is 27, 3 to the fourth is 81. But if I just do log 50 divided by log 3, we get x to be about 3.56. Okay, so we're solving an exponential equation using the change of base. Now, what does that change of base mean? If we take this original equation and we change the form of it, it'd be log base 3 of 50. That means the same thing. This is a base 3 logarithm. We could solve this, though, by doing log of 50 divided by the log of 3. So I have, in a sense, changed the base of 3 to base 10 to solve that. And I can change it to any base I want to. I could do log base 5, log base 7. I could do log base E. So then it would be natural log of 50 divided by the natural log of 3. Okay? These are really the only ones that would make sense, is to use base 10 or base E, because then you can use a calculator. All right, so the change of base formula says that for all positive numbers a, b, and m, log base a of n is equal to log base b of n divided by log base b of a. And typically b is going to be 10 or e, so I can use common log or natural log. So we can use this very simply now. If I ask you to solve an equation like, let's say 2 to the x is equal to 10, you could take the log of both sides and move your x in front and divide, but it's simply going to be log of 10 divided by log of 2. If I ask you to do log base 4 of 72, I could simplify this by just doing log of 72 divided by the log of 4. Or I could do natural log of 72 divided by natural log of 4. It's going to give you the exact same answer. All right. If you have something like this, let's say 2 to the 2x minus 1 power is equal to 10. If you use change of base, this would be log base 2 of 10. It's a funny looking 2. Log base 2 of 10 is equal to 2x minus 1. And then this left-hand side, using change of base, you could just do log of 10 divided by log of 2. Which is about 3.3. and then you'd solve for x. So you would add 1, divide by 2, and our answer for x is going to be about 2.17. Some of you might be saying, well, I can just do any base logarithm on my calculator and just enter it in. You're right there with the technology we have, but this is the meaning behind it. This is the reason why the log button is so important in the base 10 logarithm. All right, so some more examples using change of base. Log base 5 of 40. We could just do log of 40 divided by log of 5. Number 2. We could just do log of 100, which is 2, divided by the log of 7. Number 3 is an exponential equation, but if we change the form of it, it'd be log base 4 of 60 is equal to x. So then it'd be log of 60 divided by log of 4. This one here is like changing the form. It's log base 2 of 50 is equal to 3x minus 1. So then I'm going to go log of 50 divided by log of 2. Do this on my calculator. I'm going to add 1 and then divide by 3. Solving exponential and logarithmic equations. So now we can use a lot of our different processes and concepts that we've talked about. So number 1, 4 to the n plus 2 is equal to 15. Well, this is exponential. I could just do log of 15 divided by log of 4 equals n plus 2. Okay, and then just doing log of 15 on your calculator divided by the log of 4 is 1.95 approximately, and then I'm going to solve for n. So I'm going to subtract 2 from that, and n would be a negative 0.05 if I round that to the nearest hundredth. Number 2, we've got an e to the x in the problem. So I'm going to want to isolate this. I'm going to add 24. I'm going to divide by 5. And then to solve this, and again a concept we talked about before the break here is change the form. If I change the form of this, it is log base e, which is the same as ln of 8, is equal to x. And the ln of 8, I can simply use my calculator. So that would be about 2.08. Number 3 is a natural log equation. That's base e, remember? So this means e to the 8th. Changing the form, e to the 8th is equal to 3x. That e to the 8th I can simply do on my calculator using second ln. That's 2980. Actually 2981 if we round that. And then I'd simply divide this by 3. And x would be about 993.7. Number 4, I would look at trying to get this by itself. So I'm going to subtract 19. I'm going to divide by a negative 2, which gives me a positive 8. And then I would simply change the form again. This is exponential form, so it'd be log base e of 8, so natural log of 8 is equal to 3x. The natural log of 8 is about 2.07. And then I would divide that by 3. So in this case, x would be about 0.69. All right, hope this video helps. There'll be an assignment with this. Feel free to use those maroon days for feedback and review. Have a great day.